Morning, everybody. I'm going to take a holistic view of the use of energy in the logistics from the real estate to the operation and what this way may look like as we head down a more sustainable future. Now, the world runs on energy. First, let's get back to the real basics. The original power source was the sun. It warms the planet, just enough for life to be possible, the right temperature for plants and animals to exist. We also run on energy through calories and kilojoules contained in food. Using this energy, we exert effort through work and are rewarded this with money in the form of potential energy, give us the ability to purchase objects created through the effort of others. Now, for thousands of years, the dominant form of energy has always been combustion. In other words, burning things. We use this for fire, warmth, lighting, cooking, and eventually to melt metal, and industrial manufacturing was born. Now, during the Industrial Revolution, we used this combustion to drive the steam engine and catapult mankind forward with large-scale manufacturing. Then in the late 19th century, we came across electricity, and this energy form followed the same path as combustion, with light, cooking, and large-scale manufacturing. But electricity did offer something other than combustion, and that is mass communication with radio, television, and satellite communication. And as technology progressed, this also led to the digital age with personal computers, mobile phones, and data centers. We have moved into a world which simply cannot function without electricity. So now we are firmly within the electric age. And as the governments across the world have committed to reduce the reliance on fossil fuels, to reduce this addiction we have to combustion energy and the immediacy of ignition. So I've put up with some figures on them. Now, these won't mean anything to anybody, but we can all agree that these tables will certainly have not increased in value between 2020 and 2010 and 2020. These tables are, however, the power generation in the EU and the US. So while the diversity mix has changed as renewables have stepped up a bit and fossil fuels have reduced, we have not created no new energy is really being generated. So as we move into this world where we need more energy, we're not really creating any more energy. Interesting fact when you look at these numbers is the fact that China generates 5,000 terawatts of electricity just from coal. So they are definitely the highest on the list when it comes to fossil fuel use. So from that graph, you can see it's clear that power is limited. As we move away from fossil fuels and to try and slow down global warming. But with this, we're moving away from the immediacy of turning on the engine and getting the power we need. So large-scale renewable rollout is critical to pick up this gap in regional power output to feed our electric future. But along with this, resiliency needs to be built into the grid for the unforeseen, where possible future weather anomalies like what happened with the snow in Texas, can be countered and power can still be supplied. Now, the logistics sector is no different. With the massive shift to e-commerce, the facilities being built are no longer the industrial facilities of old, rather modern buildings, with many having efficiency and sustainability at the heart of the scheme, with BREEAM, LEED accreditations almost standard across the logistics sector globally, with developers across Europe pushing for net zero construction, net zero carbon in construction, and many looking to take the base building completely off the power grid. The real energy demand, however, lives in the operation. Gone are the days of a few forklifts moving a few pallets around and a low 250 kV connection to the grid. E-commerce has pushed the service expectation through the roof and brought about the requirement for large-scale automation. The machines that make the process quicker and more efficient also demand substantially more energy, from mini loads to totes, auto stores, shuttles, from 2 MVA connections for Ocado facilities to 5 MVA connections for Amazon facilities to 7.5 MVA connections for these fully automated JD facilities, from car parts to groceries and everything in between. The whole process is becoming more energy intensive, with the average automation installation requiring at least double the power of the original connection on top of the original base load. Now, the real power requirement will likely come outside the warehouse with the movement of goods. The movement of goods is the core of logistics, the movement through the supply chain. Historically, with combustion vehicles, you were provided with a known performance. And this known performance meant shipping could be planned. And there are a plethora of truck route optimization tools out there to do this for clients. However, as we move into electric vehicles, we need to become used to variable mileage capability. An electric vehicle's performance is linked to a number of elements. Firstly, the mileage might not be the same as the original diesel vehicle you start with. The geography plays a part, with hills forcing the vehicle to work harder and therefore reduce the energy output of the battery. And the weather can play a significant impact on the performance of that same battery. So in optimizing routes going forward, this is far more complex than is evident, with vehicle type, geographic terrain, and weather all now playing major roles in this complex algorithm. And the complexity does not disappear at the end of the day. With the signing of the Paris Agreement and moving away from fossil fuels, the EU has decided to fully decarbonize by 2050, with many companies and many countries looking to better that. The problem is the fact that trucks in the EU generate about 20% of all the emissions. And the only true way away from that emission load is with electric vehicles, but they need a power source. So we have two choices. You have hydrogen or battery. Now, hydrogen, in theory, can refill quicker because it's a liquid. They potentially may have a good range, lighter than battery vehicles. However, in the market, very few OEMs or vehicle manufacturers seem to be heading down this route. Electric vehicles, on the other half, have a range. Tesla have said they can do 500 miles, but these batteries are heavy and can affect the total load of the vehicle. There is, however, a huge momentum towards this type of fuel. What the problem with both is that both require infrastructure. Refueling stations capable of refueling both vehicles are currently dramatically limited. Both types of drivetrain require one key element, which may become a problem, and that is power. Hydrogen is created through the process of electrolysis and requires electricity to produce hydrogen, which then needs to be stored on site at filling stations. This is a less efficient use of that original energy generated. Battery power trucks require huge connections to grid to charge, and so much power that we could run into a major problem. So let's have a look at that problem in the EU. In the EU, there are about 4.5 million trucks with an average mileage of 50,000 kilometers. If these trucks were electric, they would be consuming approximately 1.44 kilowatt hours of energy per kilometer, which equates to 324 terawatts of power annually. If that doesn't mean anything to you, well, that's 11% of all the power generated in the EU. This figure is dramatically worse if you're in the US. In the US, there are 2.8 million Class 8 trucks. Now, those are the biggest trucks that you get. And not all the trucks, that's just the biggest. And they typically do double the distance of the trucks in Europe. And with the similar efficiency, which they aren't, but with similar efficiency, they would use 8% of the 4,000 terawatts of energy generated in the US. So this is not something we're going to be able to walk away from. So we're heading down a major infrastructure change. In the fossil fuel age, the core components, in the fossil fuel age, the core transportation elements weren't linked. You would purchase a vehicle of a certain performance. There was the trucking team would manage the fuel purchasing and the commodity risk around the oil price going up and down, how that impact on you. And then the facility engineering, the building, you might have a pump house, but otherwise you may fuel that depot. But they're all separate, not linked to the real estate or dramatically to the operation. Now it is all one thing. You need to buy a vehicle that suits your operation, a vehicle that suits your building and your building in the operation, and then you have to have a building that has an infrastructure that can support the operation and the type of vehicle. So it is all connected. Now let's look at a bit of an example. Now, not many EV trucks in the market there aren't many EV trucks in the market. There aren't, Volvo, Daimler, and Mack trucks are currently rolling out their trucks. Tesla have come along and said that their truck's coming out, and it's been delayed because of the new batteries that they are creating at their Tesla facility in Texas. But fortunately, Tesla always happy to share some performance figures. So if we look at their biggest truck they have, it has a 500-mile range, and that option requires 1,000 kilowatt connection to charge the battery, because their vehicle uses less than 2 kilowatt hours per mile. So, well, what does this mean? So if we have a truck that a Tesla truck that comes to a site and wants to fast charge, it would need at least a 1 megawatt connection. They've said they can charge to 80% in 30 minutes, but you need a 1 megawatt connection. However, you could take that same connection and you could trickle charge. You could trickle charge 10 trucks on that same connection. Okay, well that seems okay. It's only 1 megawatt. Okay, 1 megawatt. But now we have a 1 million square foot facility, and it's fully automated. We have a bunch of shuttles, and we have an auto store in the corner. We have a busy operation. 5 megawatts needed for that. And we have 80 charging bays. So we're not going to charge all the trucks, but we have 80 charging bays. And we're going to trickle charge at night. Okay, 8 megawatts. Okay, well, that's only 13 megawatts. That's an enormous amount of power. That is not a simple connection. That is an expensive connection. You would need a new substation. This is huge infrastructure investment. And this requirement pales in comparison if unplanned fast charging happens on the site with the 1 megawatt connection. Now, that, unfortunately, is a low number. What you can see now on the screen, this is an area in Southern California, part of the Inland Empire, which is the second largest logistics market in the US. This is a small piece of it. This is San Bernardino, California. You can see there's an airport running through the middle. On the top there, above the airport, is Reliance, Texas. This is owned by Hillwood. Fantastic development. And south of the airport, you can see another development, and you can see a bunch of buildings with solar panels on top. Those are Prologis buildings. So there are about 64 buildings here. Now, these buildings are typically American, and they are really large. There are about 3,000 doors. So if we think that at every door we could probably park a truck and charge, well, let's have a look what those numbers would mean if we were using current fast charging technology. So we have scenario one, which is the worst case. So every truck has emptied their batteries, come back, they've got 20% charge left, and they all need to charge. So we have 3,000 trucks, battery size of about 600 kilowatts. They need to charge 480 kilowatts of power, and the charger size is 350 kilowatt. That means the peak load on this site would be 1,050 megawatts of power. That's an enormous, enormous amount of power. And then if we look at the second option, where we have a middle scenario where half the trucks are empty, it's 525 megawatts of power. Now, just for interest, if I go back to this main image, right in the middle, you can see it says Edison Mountain View Eastern Operations. That happens to be 1,000 megawatt gas power station. So that one gas power station could just charge these trucks at the site. And to give you some context, in the US, the households in the US are far and away the highest energy users as a household. A 1 megawatt connection can power 164 homes. So if we had to go and look at the low scenario here, scenario two could power 86,000 homes in the US. Option one is 170. So we're talking horrendously high volumes of power required to charge these facilities. So what is the solution? The truth is we don't know yet. Everyone is looking at options, and technology is advancing. So what might be a solution? Well, microgrids. A concentrated microgrid on a huge site where we provide as much on-site power as possible to reduce reliance on the grid, knowing all well that the grid may not necessarily have the power available. After we've seen, before the power generation in the US and the EU, no new energy is being generated there. So let's take responsibility for that. The second key one is sustainability, removing the whole building from the grid so that every spare bit of power can be pushed into the operation, whether it's the automation or charging the vehicles. And then the third key element is demand side management. This is essentially converting the facility into its own energy center, using grid and solar to fill batteries when it's most efficient, and deploying this energy into the operation, utilizing unutilized vehicles potentially as batteries to provide power to other parts of the facility when required. But the most important element is optimizing the full supply chain, from truck routing to the facility design, to the automation layout within the facility, to fully controlling the recharging strategy, and through to the optimized energy use across the building to ensure all power is available for the automation and for the process that needs to take place. And thank you very much for that.
Thank you very much for that as well. One of the first questions, I think, which I also got asked was, when do you think that EVs will take over the logistics? And
currently at the moment, we've seen that like DHL is pushing. DHL is one of the first movers, and DHL is pushing really hard in testing big EVs, big EV trucks. Big EV trucks aren't really on the market at the moment. Volvo is definitely at the forefront. Volvo have rolled a number out across in the US that are being tested with big fleets. And they have an arm called Mack Truck. Mack Truck is rolling out a bunch of EV vehicles in terms of garbage trucks, because those are a much smaller route. So those are being tested. But in terms of long distance mileage, I think it's going to take a while before people are convinced. I think the biggest concern is probably infrastructure, in terms of, is there infrastructure to provide the charging? And that is probably the biggest one. It's fine having a truck that can drive the distance, wonderful. But if it gets to the site, can it be charged? And who's willing to make that commitment? I know I think the drive will come when there is a big user, like a big retailer, and they go all in, and they sign up with like a Volvo or the Mercedes, and they just take their truck and they just run it. And once they do that and the market becomes comfortable with the fact that it can be done, I think then we'll see more take-up taking place. But I know Volvo's looking to get pushed much harder towards the end of 2021, and I know Tesla are pushing for early 22 for their trucks. So we'll see. But it'll take a while before all the trucks are off the road.
Do you think that one of the major problems is the technology, or the money, or lack of interest?
You know what? Nothing. When it comes to nothing drives decision making like sentiment and law. So all you need is to be seen as the one who's not going green fast enough to convince, and you start losing clients or investment, and then you'll say, okay, great, let's make a plan. Or like what's happening in the US, in a number of the states, and like here in the UK, but a number of states in the US are forcing electric truck manufacturers and truck sales, particularly in California, by 2035, they want to have 100% of all trucks sold in the state have to be EV. But the thing that they've done is, instead of giving an end goal, they've given intermediate goals, and the intermediate goals are pretty hard. Pretty quickly you have to 35% of the trucks, and 35% of the trucks is quite a lot that's a lot of trucks. So to do that, you need the infrastructure in place. So I think it's very much a chicken and egg scenario. It's like, is the technology in place? Are the trucks available? And is the legislation in place? And is the money there behind it? So there are a whole bunch of things moving, but I think the technology is moving in the right direction. We've seen, the momentum behind the electric vehicle, from a passenger perspective, is definitely there, with, General Motors and Ford in America just smashing that out the park at the moment. They're really pushing hard on that, and because they see the opportunity. And I think Europe is definitely leading the way, and it'll be interesting to see when it happens and how quickly it takes place.